G'day guys, it's Alex here, Victor Kilo 2 Papa Radio Charlie. Just making another video in my line of videos concerning Clansman radios, and in this case, Clansman radio equipment. Today we're going to be looking at the Clansman battery charger. Okay, these particular battery chargers are designed as a float charger and go into vehicles. The whole idea is the battery's plugged in and it gets charged as the vehicle's running, and it operates as a float charger for the Clansman vehicle systems. But many people out there are using these chargers at home with a power supply to charge their batteries. And I'm just wondering how many of these chargers are out there that are actually not working, because I've been looking at a whole bunch of these lately that have been disabled, not working. I bought one that wasn't working. I had one here that had some problems, and I've been recently given a whole heap of these things from members of my local armoured vehicle club that have these chargers that are inoperative. Either they've got them inoperative or they've made them inoperative, I'm not sure. But in order to understand the way that these particular chargers work, I've gone through a whole lot of exercise here in learning basically how they all work. So let's just have a bit of a look at the charger and how it's put together and how it operates. And last of all, we'll look at some of the faults that occur with the chargers and how to repair them. And lastly, we'll look at how to set them up after you've repaired them. Okay, so first of all, here is the charger. As you've probably noticed, it's quite a robust box. It's got these protective little fins around the side, typical Clansman. This is a 28 volt model. They come in 14 volt models as well, and they are very similar in size inside to each other. There's an input socket. There's the output socket that goes to the battery, and this little nylon piece here is a mod that they decided to put on to hold the plugs more securely in there. We've got a couple of on-off switches, one here that operates the lamps. We turn that in the off position if we want to operate the charger in a clandestine sort of a situation, or we turn it on and the lamps are displayed. We've got an on and off switch to turn the charger on and off. So when a battery's under charge, the green light comes on as soon as you turn the switch on, and that's proceeding, so meaning it's proceeding in charging. And when it gets to fully charged state, it switches off and the green light comes on over here to illustrate to us that the battery's fully charged and the charger's been turned off. So that's basically what we're looking at. So let's have a look at what lives inside these things. Okay, and by the way, these are for what they do, these are a very complicated little item, I'm telling you. Okay, we've got a PC board on the bottom, and from recollection, that is PC board number 2. That's PC board number 2. And then, as we look through it, it's made up of layer upon layer of PC boards. So there's PC board number 2. There's PC board number 5, the small one here. PC board number 3 with all of the big regulators and rectifiers on it, and lastly there's PC board number 4 up here at the top. Okay, so what we're going to do now, we're going to slip over and have a look at a diagram illustrating these particular PC boards. So over to the diagram. In order to understand how they work, I thought it would be best to put together a bit of a flow diagram on the different parts of the charger and how they sequence to finally end up with a charged battery. So I've put pencil to paper here, and we'll just quickly go through what we've got. Okay, so we input 14 or 28 volts into these units depending on where, or should I say what model we've got. And both models work very similar, and they're quite similar inside. As a matter of fact, this one here is a 28 volt one, as you see. Okay, so the very first thing that happens after the power comes into the unit, it goes through a DC filtering circuitry in the unit to take out sort of any possible spikes that the alternator or the charging system on the vehicle may produce. And it's a pretty extensive little filtering circuitry on the unit. And then it goes off to the switch, the on and off switch, and there's protection against reverse polarity by a nice big thumping diode there as well. Then we move on to some more protection that it's got. It's got some over voltage protection on the unit, which sort of I think it's limited around about 33 volts. So I'll just write that down there, 33 volts. And if the voltage goes over that particular voltage, the unit turns off. Okay, so next step along the line, there's a 20 kilohertz generator by an Astable, which vibrates at approximately 20 kilohertz. It's not dead on it, so you know it's either this way or that way. And that enables the DC to be transformed up. And there's the next section is a high frequency transformer section. After we get through that, we end up with a high voltage rectifier and filtering section of the charger, and it gets the voltage up around 60 to 70 volts DC. Okay, now in order to charge these particular batteries at the right rate, there needs to be some sort of a regulator in there, and this particular unit, a pulse width regulating system, which automatically adjusts the charge rate on the battery. So as the battery, how could I say this, increases in voltage as it goes through the charging, this thing here's got a maximum rating set onto it, and it's automatically set by a potentiometer on there, but we'll get there a bit later. But the mean voltage there is about 31.5. So as the voltage rises up during charging, it gets up to about this level and won't go any higher. So that's the regulator. It's set at the highest voltage. And then, of course, there's a current limit in the unit which limits the charge current to 1.25 amps. And that's pretty constant through the whole charge cycle. Okay. Now, next, there's a battery temperature sensing circuitry, where inside the battery there's two sets of diodes, two diodes in series in each set. One set just lives behind the plug socket on the battery, and the other set lives deep inside where the cells have been packed into the battery. Okay. Now, next in line, we've got a temperature comparator. And what this temperature comparator does, it compares the voltage drop across these sets of diodes, and the temperature coefficient of the diode inside the battery as it charges up changes, and that enables the battery charger to get some information on how the temperature of the cells are warming up and when it's reaching the time to cut the charger off, being completed charge. And that's decided by some logic switching inside the unit, which looks at these changes in diode currents. Okay. And when the logic switching circuitry decides that the difference between these two sets of diodes is such that we get to the fully charged state, and it turns the unit off and the green light comes on. So not only do we get a full battery, but we get a changeover of the lighting on the front from yellow to green. And then we end up with a fully charged battery. So that's the state of play when it comes to the charger. Okay. Now that we've gone through the flow chart, let's just have a bit of a look at the circuit boards and talk about each individual step along the way. Okay. All right. We start off with Unit 2 here. There's Unit 2 down the bottom, and that's the circuit diagram for Unit 2. Our supply comes in from the vehicle at this point here, and we go to the surge suppressant section. Okay, so we've got two back-to-back Zener diodes there offering a surge protection. We've got two big inductors to sort of help smooth things out. We've got a bit of a capacitor across there, a bit of a small one to take any small spiking out. Up through a fuse, I think that's about 5 or 6 amp fuse. Up through the on and off switch. Then we go to a diode that protects against reverse connection. so all sorts of protection in this part of the initial battery charger. And then we come on to the rail inside the board. Okay, and by the way, across the rails, we've got this dirty big 80 microfarad capacitor there that helps with smoothing as well. Okay, so yeah, pretty extensive sort of a smoothing, but you remember there's a vehicle supply with all sorts of glitches and spurious inputs that could come in, so there's protection being put in there for that. Okay, once we get through that part of the circuit, we end up into the supply rail about here, but you notice down here there's a bit of a break in the supply rail, and here there's a series power transistor, and this can be turned on and off. Okay, and this works in conjunction with these controlling transistors and this particular Zener diode here. And what this part of the circuit here is doing is looking at the rail voltage up here, making sure that it doesn't rise above 33 volts. Because if this arrives above 33 volts for any reason, using the Zener diode here as a constant voltage source for this transistor in conjunction with this transistor, which will change its state according to the rail voltage up here, it actually turns off the series power transistor down here. So voltages above 33 volts, transistor off. Voltages below 33 volts, transistor on. Okay, over voltage protection. And by the way, this diode here, it's a Zener diode, but in fact in the drawing it's marked as a normal diode. I've put the little legs on there to help people out. It's a Zener. There you go. Alright, so we move from that part here into the astable section of the board, and we've got these two transistors here running as an astable vibrator, and they're set up by their frequency by these couple of capacitors here. Okay, so we get a 20, when I say 20 kilohertz, it's approximately 20 kilohertz, could be up and down a little bit. Square wave being produced here, and over we go to the first transformer. So the whole idea is to get this voltage up from about 28 volts up to about 70 volts. So we go through this first transformer here, and the signal goes out from this transformer at 20 kilohertz and 1.5 volt peak to peak sort of waveform, square waveform, and that gets applied to the next board, and that board happens to be I think it's board 5. No, I think it's board 3. Anyway, we'll get to that board next. But before we get to that board, let's just have a look at our circuit board here and try and sort of recognize the bits and pieces. Okay, we're coming in here. These are the big inductors that do the surge suppressant. We've got a couple of big Zener diodes there going back to back. We've got a big fuse, or sort of 5 amp fuse here. And look, this particular capacitor, I've only put this one on here in a temporary state. This is not the right one. It's supposed to be 80 microfarads. I only put this one on here for testing while I've got the other one on order. But that's the surge protection area of the charger. And if we go here and we have a look underneath here, we see the switch. That's the switch that comes into play as well. Okay. So from there we're heading off up to the protection part of the circuit for the over voltage, and that's the two transistors that work for the over voltage section of the charger. And of course the big series transistor is located on our power board underneath. Okay, so that's that part of the circuit. The astable, these are the two transistors that control the astable vibrator, and of course this is the first transformer. I think this one here is an inductor, and I think that's the transformer there that does the 20 kilohertz. Okay, so basically that's what our board is doing. Our board 2. Okay, so we'll move on to the next board. Okay, we're now looking at board 3. This is board 3 here in the middle, and this is the board that's got all of the heavy duty switching and power regulation and rectifying, transforming section of the charger. You can see down there in the background we've got some big transformers and inductors. There's all sorts of diodes. Yeah, get a bit of a look. There's power diodes in there as well, but they're on the other surface. So if I lift that up there, you'll see them down inside of there as well. So that's the board that we're looking at, the serious power section of the charger. So let's have a bit of a look at the diagram there. Now I mentioned coming out of the previous board, we had the 20 kilohertz 1.5. Okay, so here we go again, switched through a couple more transistors, and they're located on this board here. Okay, and then it goes to a pretty heavy duty transformer inside, rectification, filtering, and coming out up at our board 4. These other transistors that you see are located on this particular board 3. These are all of the, well, one of them is the switching transistor from the board before, and the other ones are switching and regulating transistors on the next board that we're going to look at. So all of the power switching and power work's done on this particular heavy duty little board in there, and that's unit 3. We'll move on to the next one. Okay, moving along to unit 4. Okay, up from the previous board, we get the high voltage DC coming into this particular board, and yeah, that's a couple of test points there. We can test that test point, I think it's 1 and 2 on this board, and it's got another nice big thumping capacitor across there to help us filter it out. So we're up here now onto this particular regulation board at around about 60 to 70 volts DC. Okay, so let's have a look at what's going on this board. We've got first of all, let's look at the current limit. So this particular part of the circuit up here is the current limit part of the circuit, and the current limit is set up by that potentiometer there, which is R26, I think. And if we look over here, there's our R26, and this is the section of the current limit. Okay, on this particular board. Right, and when we look at the regulation to give us our maximum output voltage regulation, that's taken care of down here, and we get the regulation through it's pulse width, and the pulse width's generated in this part of the board here, and that maximum voltage for your charging voltage is set up by that little resistor there, R11, and that enables us to set the maximum battery charging average voltage at 31.5 approximately. Okay, and let's have a look at where that is. I think that's R11, and there it is there, R11 on the board. And these are the little transistors here to do with the pulse width, yeah, frequency generation for that. Okay, all right, and when that pulse width pulses are given to these transistors on the previous board, they supply the voltage to the charger, which are the output terminals up here. Okay, so we've got the current limiting the current. We've got this part of the circuit down here giving us the maximum output voltage. And if we look at this part of the board here, we've got the comparator section, and this is the comparator that looks at the ambient sensor in the battery. That's the one that lives just behind the plug socket, and then the battery sensor, which lives deep inside the cells. And when the difference between these two are such, drives the Smith trigger, and the lamp driver switch. But all this is done in a logic area down here on another board. We'll get there in a minute. Okay, so yeah, depending on what charger you got, depends on the logic levels used to do the smart switching, so to speak. And to set up the comparator, the difference between these ambient temperatures, there's a little potentiometer there, R19. So if we look on the board here, R19, that's where that setup is done there as well. Okay, so current limit and regulation board. We'll move on to the next one. Okay, the next and last unit on the board is the unit 5, which is this little board here. This is a bit of a mystery board, this one. This is where the logic on how the battery charger works, how it senses the difference in between ambient and charge temperatures in the battery, and decides to turn off the battery charger and do the light changeover. Now look, when I say it's a bit of a mystery, it's not really a mystery when you look at it. These are TTL gates and they're mounted on PC board right there. If you look at it, you'll see them in there. All of the pins associated with them, they're very difficult to see, but there they are there on the board there. That's the logic board. But when I pick up another battery charger and I look at this one, there's no board. There's no board there at all. So something's changed in the manufacture of these chargers, and something's changed dramatically in the way that the logic system works. Whether they've done an updated mod where they perhaps have replaced all of this switching logic with one IC and mounted it on the PC board, I haven't been able to figure that one out yet. But the only diagrams that I can find for the charger have unit 5 in them. So it is a bit of a mystery to me. Obviously a mod or an update has eliminated that board, but there you go. Okay, the next thing that I want to sort of go over are the usual failure points that I've found in my experience repairing these chargers. These are the sort of the typical things that you look at, and they seem to occur more often than others. So let's start. I found that the majority of, well, not the majority, but a large majority of the failures seem to be on the input card. This is the card that does the surge suppressant and overvoltage protection and 20 kilohertz generation. So let's have a look at some components that I've found myself that have seemed to fail a lot. Okay, this capacitor here, this 80 microfarad capacitor, that by the way, there it is there. That's what it looks like. This one over here, I haven't got a replacement yet. I've only put a smaller one in for test purposes. But that capacitor there, I've seen that blow up on 2 occasions actually, 2 charges. So yeah, it just blows the leads off one end. Just blows it off one end. But there you go, that's one of the points. Okay, the next sort of area that I've seen failure, of course the fuse, that's what it's there for. And the switch, the actual on and off switch. Now I've seen these fail in such a way that they develop a high resistance joint on the switch, and the voltage here that should be 28 volts ends up something like about 7 volts. So I know that in normal circumstances you would simply change that switch, that fellow there, you'd simply change it, but to try and find another switch for these particular switches is just almost impossible. So what I've actually found that I've done in the past, I've actually pulled the switch off, and there's 2 screws in the back of the switch. If you look carefully, you can see them there. You take the 2 screws out and you can actually pull the switch apart, and it comes apart quite neatly, and you can actually clean up the contacts and put it back together again. It's quite a successful repair. So yeah, the switch is a bit of a failure point I found in the past as well. Okay, so we get up here to the over voltage protection, and all of these sorts of things are occurring when the charger's been abused by being connected to something that it wasn't really supposed to be connected to, or the vehicle supply's gone crazy, or someone's accidentally oversupplied it on a bench situation or something like that. The next thing that I've found that fails is this transistor here. I've had that kaput as well. So yeah, sort of look at these transistors as a failure point as well. And when we get up here to the 20 kilohertz generator, of course, I've found the transistors do fail. And look, it's probably a good idea when you get a transistor to replace them both. But one other thing that I found has changed its value over time is these little capacitors here, these 2.2 nanofarad capacitors, and they'll change in such a way that instead of generating 20 kilohertz, it'll be up around 40 kilohertz. But it's not really designed for that, for the transformers to work efficiently. So yeah, you really need to be looking at this generating approximately 20 kilohertz, and look at those little capacitors there. I think they're ceramics, 100 volt, but a little bit difficult to get, but there you go, but you can get them. Okay, we come up to here. I haven't really found any problems associated with this area, luckily so far, with the ones that I've been repairing. But you can monitor easily the frequency that this thing generates by looking at that terminal there and that terminal there to this terminal here, 19. So it's between 2 to 19 and 3 to 19, and with your cathode ray oscilloscope, and you can see these 20 kilohertz 1.5 volt peak to peak square wave generation here at this point. Okay, we'll move on to the next board. Okay, just moving on to the regulator board here, looking at the typical failure points that I've found. Let's look at the current limit. I found that diode there has failed on one particular unit that I've repaired. Let's have a look at that. Turn this one of these over and I'll have a look at that diode where it lives, and that's that diode just there. And look, I've replaced that with just a single silicon diode, a 1 amp general purpose diode, and that's been good enough. So yeah, and typically when that diode fails, you can't do any current regulation adjustment at all. Okay, so that's one of the areas that I've found it fails. And another area on the actual voltage side of regulation, I've found the main regulator transistor, this one down here, and this is situated, as I said before, on the power section board here. I've had that particular one fail on me as well, and it's failed short circuit. So when it fails short circuit, you're getting maximum voltage out on your batteries all the time. So they're being subject to over voltage. So as the voltage builds up and builds up and builds up, as the charge cycle's going, it doesn't stop at 31.5. It actually keeps going up and up and up and up until the ambient temperature changes on the diodes inside the battery and turns it off. But generally the charger runs very, very hot. A lot of heat being generated by this transistor here that's shorted out. And look, I've been able to find local replacement for this. I think I've used a 2N3773 TO3 case transistor that you can buy down the road. Works brilliantly in that situation, instead of trying to chase all around the world to try and get the original replacement. But as far as failures are concerned, that's the general area where I found most of these problems occur on the chargers that I've been repairing. Okay, let's just go through a quick diagnosis flow, trying to find out the area that's got a problem. Imagine we turned on our charger, connected to our bench supply, and it was dead. It just never did anything, like typically they do. The first thing that I'd be checking, guys, would be across test point 1 to test point 2, and that should be 28 volts across there. If I wasn't getting 28 volts across there, and by the way, that's that capacitor just there, that capacitor there, across that capacitor there. And if I wasn't getting my 28 volts at that point there, I'd be saying I got a problem with the switch, the blocking diode, the fuse, or perhaps one of these filtering inductors. I'd be looking in that area. Okay, so imagine that that's working okay, but we check from test point 3 to test point 1, and we find there's no voltage there. That would indicate to me that my over voltage protection circuit is faulty, and I'd be looking at why this transistor is not switching the main series regulator on, or maybe the series regulator's got a problem in that transistor. But I'd be looking in that area of the circuit. Next, I'll be looking up here to make sure that I've got I've got my 28 volts across, well, I've done that already, 28 volts across the rail there. I'll be looking at my 20 kilohertz 1.5 Astable running, giving me a signal up here between terminal 2 and 19 and 3 and 19. And if that's not running, and a dead giveaway as you can hear it, a high-pitched scream, I'd be looking at failed transistors here and here. And remember, the value of these will give you a different value of oscillation. Okay. So moving right along, we'll get up here to the regulator board. So after this is comes out of here, it goes through the main transformer on the board in between. That was that board in between there. Okay, so we get up here to the regulator board. Next, I'll be checking between test point 2 and test point 1 on the regulator board, and they is test point 1 and test point 2. This is on the number 4 board. I'd be checking to see if I had, in fact, about 70 volts, 60 to 70 volts across there. And if I've got that happening, hopefully my battery charger will be operating. And yeah, then I'd be starting to look at some values. So we're going to go over those values pretty soon. But if you've got the voltage across there, you would expect the yellow light to be worked and set up by the Smith trigger and the comparator, so that would be working there. Okay, so let's just have a look now at possibly how we could set up the charger and make sure that it's in fact working to specs. But unfortunately, I don't have, and I don't know anybody that does have, a battery charger test unit. I'd love to have one of those, but unfortunately I don't. So I've just got to do the best I can with what I've got. And it seems to work okay for me. I'll explain what I do, and perhaps you can follow it and get similar results as well. Okay, after changing components like, say, the regulator transistor down here or the current limit section of the board, you need to really make sure that the battery charger's operating to specs. And the specs are a current limit of around about 1.25 amps and an output voltage of about 31.5 come 32 volts. That's what the manual sort of says. So what we do, or what I do, I simply get myself a discharged battery, something that's got about a quarter of the charge left in it, and I'll put it on the charger and turn the charger on. Okay. But before I do that, what I'll actually do is I want to monitor the current coming out of the charger. It's a little bit difficult to monitor it because it comes out on a plug and goes into the battery on another plug. Makes it a little bit difficult to monitor that current. So, in fact, here on terminal 14, that's 16, 15, 14. Terminal 14 here, I lift that wire off, and between the terminal and the wire, I connect my multimeter on the amp scale. Okay, so I can actually measure that current. That's the output current from the charger. So when I turn it on, I want to expect to see on my meter 1.25 amps. And if I'm not getting 1.25 amps, then I'm going to go here and I'm going to give that a tiny little bit of adjustment, that R26, and that was just there. So I'm going to adjust that for 1.25 amps. Okay. Then I go across and I'll put my multimeter on the volt scale and I'll put it across the battery terminals. And for a quarter remaining charged battery, I would expect the voltage to be sitting down around about 26 volts, 26.5 volts. And over the course of about 4 hours for this particular battery to charge up, that voltage is going to increment by tenths of a volt every now and then on a march up towards about 31.5 volts. So what I've got to do is I've got to monitor that. So just come back now and then, check it, come back now and then, check it, and you'll see the voltage slowly marching up towards the 31.5. So the trick is, when it gets up about 4 hours later, when it gets up around about the 31.5, it's time to sit down and just sit and wait and watch. So if it jumps up, I like to set my battery charges about 31.5. So as the charger gets up to 31.5, it goes to 31.51 or 52. What I'll do is I'll wind back the potentiometer just that little bit and wait again. And what I want to do is I want to make sure that I stop the increasing of voltage, and I want to maximize it out at 31.5. So I'll get to a point where I adjust that potentiometer there and the voltage doesn't climb anymore. The battery's still on charge, but it just doesn't march up anymore. So that's set my voltage limit at 31.5, and probably 10 or 15 minutes later, when the temperature between the ambient and the battery diodes within the battery case change in such a state that the comparator will trigger a signal to the logic, and this is where the connections are down to the logic board. That'll give a logic signal to operate the Smith trigger and turn off the battery charger and change the lights over. So that's how basically I set up my battery charger, not having a battery charge test equipment. Works for me, guys. The manual is quite complex. It's very good. It's got lots and lots of test point readings for fault finding. Too much to go into it for this video, but I sure hope that this bit of a description on how they work and my basic fault finding can help you people out there to try and conquer a crook battery charger. And interesting, as I pointed out before, this one's got the logic board in it, the little board there, and this one over here doesn't. But like I'm saying, it's probably all contained in one integrated circuit on this other one now. But there you go. Clansman battery chargers. Love them or hate them. They do a good job. They do a good job of charging the battery, but there's a lot of other chargers on the market these days that will charge the battery for you just as well. There you go. I hope that helps you out there. This is Victor Kilo 2 Papa Radio Charlie. Alex here saying 73.